Oke, Assalamualaikum warahmatullahi wabarakatuh. First of all, let me introduce myself. My name is Muhammad Aril Praditya Kusuma with name 25091387055. I'm from class 2025 International. Today I want to presenting about superconducting material. Next. Okay, first introduction. A superconductor is a material that can conduct electricity with absolutely zero resistance when cooled below a specific temperature known as the critical temperature or ATC. The phenomenon of superconductivity was first observed by H. Kamerlingh Onnes in 1911 when he cooled mercury to 4.2 Kelvin or equal a minus 268.95 Celsius. Next. A background. In normal conductors like copper or aluminum, resistance converts electrical energy into heat, causing power loss. Superconductors eliminate this resistance completely, allowing current to flow without any energy loss. This phenomenon opens vast opportunities for future technology. Next. Then, characteristic of superconductor. First, zero electrical resistance. Second, expel magnetic fields or Meissner effect. Third, have a specific critical temperature or ATC. Fourth, perfect diamagnetism. And fifth, electric current can flow indefinitely without a power source. Next. Types of superconductors. It has two types. First, type 1 superconductors, usually pure elemental metals such as lead, Pb, tin, Sn, or mercury Hg. Exhibit complete magnetic field exclusion or perfect Meissner effect. Operate at very low critical fields, easily lose superconductivity in strong magnetic fields. Primarily used in research and theoretical studies. Second, type 2 superconductors, composed of metal alloy or complex ceramic compounds. Good example of NBTI and YBA2CO3O7 can withstand strong magnetic fields and carry higher currents. Used in MRI machines, particle accelerators, and maglev trains. Represent the majority of practical superconducting materials. Next. Alright, the next is the Meissner effect. The Meissner effect is discovered in 1933 by Walter Meissner and Robert Oschenfeld. When a material becomes superconducting, it completely expels the magnetic field from its interior, unlike a normal conductor. This results in a phenomenon where a magnet can levitate above a superconducting surface or vice versa. The Meissner effect is the key principle behind maglev transportation systems. Next. Next we have examples of superconducting materials. First, with metal and alloys, with example Al, Pb, Nb3Sn, Nbti, and Mgb2, with Tc 36 Tck, and we have organic superconductor, heavy fermions, borocarbide and boronitride oxide base, copper oxide base, and iron arsenide. Next. Next, application of superconductors. With first, we have maglev trains or magnetic levitation trains. Use magnetic repulsion to float above the track. Second, we have MRI or magnetic resonance imaging. Generate strong magnetic fields for medical imaging. Third, we have efficient power transmission cables. Deliver electricity with zero energy loss. And last, we have quantum computers and high precision sensors. Utilize stable magnetic fields and resistance-free current flow. Next. Next we have challenge in application. First, with extremely low temperature requirement. Most superconductors operate below -200 degrees Celsius, requiring liquid helium or nitrogen cooling. Second, high cost of cooling and maintenance. Cryogenic systems are expensive and energy intensive. Third, material fragility. High temperature ceramic superconductors are brittle and difficult to manufacture. Fourth, limited magnetic field range. Exceeding the critical field destroys superconductivity. And last, with scalability issue. Large-scale industrial production is still complex and costly. Next. Future prospects. First, with energy revolution. Zero loss power grids could drastically reduce global energy waste. Second, transportation. Faster, quieter, and more efficient maglev trains. Third, medical advance. More affordable and precise MRI and imaging systems. And fourth, quantum technology. Superconductors will remain the core of quantum computing and sensors. And at last, sustainability, a step toward achieving clean and efficient technologies aligned with the SDGs. Next. In conclusion, superconductors are a milestone in modern physics with enormous technological potential. Their unique properties, zero resistance, and magnetic field expulsion enable groundbreaking innovation. Despite challenge of cooling, cost, and material stability, research is rapidly advancing. The development of room temperature superconductors could completely transform energy, transportation, and computing systems in the near future. Next. Here's a few references I used to making this PowerPoint. Next. Alright, maybe that's all from me. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.